All right, this is Coach Williams, and we are going to go over our notes for 7.5. We have learned in Chapter 7 about polynomials. We've learned about monomials, binomials, trinomials, polynomials. We have added polynomials together. We've subtracted them from each other. We have multiplied them together. We have divided polynomials, and we've used long division and synthetic division. And now we're going to actually solve or find values from our polynomials. And we also are going to learn how to factor these polynomials, which will help us to do some solving eventually as well. So first we need to get some vocabulary terms out of the way. And factored form, and this is obviously in reference to polynomials. Factored form is going to be a polynomial. And I know you're thinking, Coach, it's Valentine's Day here today as we create this video. So happy Valentine's Day to everyone. And I'm writing in pink because it's Valentine's Day. It has nothing to do with the fact that I've written in pink and green all year because these are the pens I have. I chose this one specifically for this day. So this is a polynomial written as a product of factors. As a product of factors. Now, let me give you an integer scenario first. If I'm going to factor 10, how can I write 10 as a product of factors? What factors make up 10? 5 and 2. So I'm going to write 2 first. 2 and 5, or 5 and 2, same thing. What's another factored form of 10? No, it's a factored, so it has to be a product of two things. 1 times 10, very good. 1 times 10. All right, so that that would be the factors of 10, things multiplied together to make 10. And so we can see that just by taking, the factors of 10 itself, and we can see which ones be multiplied together will equal 10. We can do the same thing or apply the same principle whenever we're talking about polynomials. And as an example here, we may have x squared plus 2x. If I factor that, okay, what can I take out of both terms? What can I take out of both, or what can I take out of that resides in both terms? We'll say, what factors can I take out? And maybe the easiest way to see this is to look at the factors of each term first. This is the same thing as x times x. And this one is the same thing as, and you could always throw a 1 in there, so don't forget that. You could always throw a 1. And then we've got the factors of 2x, which would be 2 times x, and then obviously times a 1. And 1's always an option, we'll say. So if I'm going to factor this out, or factor something out of both of these, what is in both terms? What is a factor of both terms? And the only thing that we can see that's in both of these is an x and a 1, of course, but the 1 doesn't really count necessarily in this case, not for this purpose. But we've got an x that we could pull out of both terms. And then the other factor would be, well, if we take one of the x's away, so let me mark out one of these x's. So one of those x's is gone, and one of those x's is gone. So what is left here for the first term when we take the x out? Well, just one x is left. And then if we take the x out of this term, what's left here? 2 times 1, so we're going to have 2. So if we look at this, this is the factored form of x squared plus 2x. So x times x plus 2 would be the factored form. Okay? And we're going to apply this as we move along, especially when we get to finding the roots. We'll kind of explain the roots as we move here to the next vocabulary term. Roots can also be called, let's write down a few words that we can relate to here. The solution, it could also be called the zero, Okay, and we can also see this as the x-intercept. Okay, so a root is a solution to the equation. It's a zero of the equation or an x-intercept. Now that should make a little bit of sense. If it's going to be an x-intercept, it's going to be where x equals 0. Okay, so we're going to see some scenarios where this is going to play out, where x is going to have to equal a 0 or potentially equal 0, and that's going to be what we call roots. We have another term here, repeated roots, and I'll show you an example of that in just a minute. But repeated roots will be two roots that are the same. Okay, so two roots that are the same. And you'll see this in this example right here. What if I had x plus 3 squared? And I said, well, let's set this equal to 0. Okay? And I want to find out what would make this equation on the left equal a 0. Well, there's this little thing, we'll see this zero product property down here below, and we'll just kind of work our way through as we explain it. If I have two numbers, or if I have 20 numbers, and one of those numbers is a 0, if I multiply them all together, what is my end result? If I had 10 times 21 times 5 times 650,000 times a negative 1 times 0, what is the whole product going to be? It's going to be a 0. Because anytime there's a 0 in your factors, the end result, or the answer, would be a 0. All right, so taking that logic, we have this property called the zero product property. That if two real numbers, the product of two real numbers is a 0, then one of the numbers has to be a 0. So if I broke this up into two factors, which I can do that fairly easily, I can say x plus 3 times x plus 3 equals 0, right? Is that not the same thing as this? All I did was take that into its two factors, which is just x plus 3 times x plus 3. Well, if this whole thing multiplied together is supposed to equal 0, doesn't that mean that one of these has to equal a 0? And the answer is yes, one has to be a 0 if it's going to be equal to 0. So we would set these equal to 0 and find out what makes that binomial, in this case, a 0. So we would set x plus 3 equal to 0. We only have to do it once because there's two of them. And then we move this positive 3 over, which makes a negative 3, and that would take it away from this side, or we subtract 3 from both sides, same thing. Moving and subtracting in this case is the same thing. So x would equal a negative 3. But x equals a negative 3 for this one, and x equals a negative 3 for that one. So in this case, this is the answer or solution for that and that one, and it's the same answer. So this is called a repeated root. You may also hear this called a double root, where it's the same number. Okay, and so we've already kind of mentioned it. I'll just read through it though. But if the product of two real numbers is 0, then at least one of the numbers is 0. If a and b, some variables, are multiplied times each other, a times b, and it equals 0, then a has to equal 0, or b has to equal 0. Okay, let's look at some of these examples, and I think that some of this is going to start coming together for you. On the extra practice number 1, we've got x times x plus 5 equals 0, and we're finally, we've been rewriting, we've been simplifying, we've been doing all kinds of stuff, but we haven't actually been solving, but finally we're going to be able to solve some stuff in Chapter 7. So we'll solve the equation. We're going to solve for the roots of this equation here, x times x plus 5, and this is in factored form because I've taken this, broken this apart into two factors. All right, so x, we know that if we multiply two factors times each other and they equal 0, then one of them has to be a 0. So we'll say, let's set the first one equal to 0. Well, that one's pretty easy. x must equal a 0, or a possibility of equaling 0. The other one is this term right here. So we'll set it equal to 0. And what would make this expression equal 0? Well, we can take the 5 across the other side, which makes it become a negative. And so x would have to equal a negative 5. So my two roots would be 0 and negative 5. What would make each term become a 0? We know that one of them has to be. So my two possible roots here, or solutions, would be x equals 0, x equals negative 5. Okay, on the next one, these are pretty easy as long as it's got this term sitting out front. We don't have to do a whole lot of moving around. But this one, again, we can set the first term a equal to 0, and that would just be it. There's nothing else we need to do to that one. So a could possibly equal 0. Or a minus 12 could be what is supposed to equal 0. And we can take the negative 12 across the other side, which means we add it to both sides. And so a would equal a positive 12. All right, so number 3, we'll have the same concept. We've got a 5 times p, but that's not really going to matter much. When we set 5p equal to 0, we'll notice again right away that p still just is 0. We'll see that pretty quickly. But we have these two factors. We've got this 5p, and then we have the p minus 2. So 5p equal to 0. We set the first factor equal to 0. Solve for p. We divide both sides by 5, and obviously p is just going to equal 0. All right, we do the second part of this one. We have p minus 2. We set that factor equal to 0. And again, this is becoming pretty easy. We know we can just move that across, and p is going to equal a positive 2. So our possible roots are 0 and 2, or solutions are 0 and 2. Now, what you're going to start noticing, as long as the coefficient of this variable is a 1, and you're setting this thing equal to 0, you just take the opposite sign of the term after this variable. So this is a p minus 2. What would make a minus 2 0? A positive 2. So you just change the sign, and that's your solution, or root in that case. All right, let's look at the next 3. Again, we're setting each factor equal to 0 to see what possible roots or solutions we have here. We can do this one again rather easily. We have coefficients of 1. We know that all it's going to mean is we've got to have a positive 2 to make the negative 2 go away. We've got to have a negative 1 to make the positive 1 go away or become 0. And so the first one, we're going to have c minus 2 equal to 0. Well, we know c is just going to equal a positive 2 there. And if c plus 1 was equal to 0, we know that c would have to equal a negative 1 to cancel out the positive 1 to result in a 0. So our two roots or solutions would be c equal to 2 or c equal to negative 1. Okay, on number 5, they give us a little bit more of a challenge. Because on number 5, there's not a single or not a 1 coefficient, in front of the variables here. We've got a coefficient greater than 1. So in this first one, we'll set 2b minus 6 equal to 0. And we'll take this negative 6, across the other side, which means we add 6 to both sides. So then we bring down our 2b. It's going to equal 6. We'll divide by 2, and b is going to equal a positive 3. Okay, so that's one root. And then we'll set the other side equal to 0. So 3b plus 18 equals 0. Again, we'll move our integer term across. Subtract it from both sides. 3b is going to equal negative 18. We divide by 3. Divide by 3, and b is going to equal a negative 6. So, two possible roots or solutions here are going to be b equal to 3 or b equal negative 6. Okay, on number 6, carrying on the same methods and steps here. They just take and put the s's at the end, so that's not a big deal. We can still solve. We've got 3 minus 5s equal to 0. And so on this one here, we're going to have to, and I think it'd be easier if I just take and move the 5s to the other side, and that just leaves everything positive. So if I take the 5s to the other side, I've separated my variables and my constants here. So I have 3 equals, again, that would be meaning that I would have to add 5s to both sides. 5s, and then I would divide by 5 and divide by 5. And so s would equal 3/5. S would equal 3/5. If I did the other factor and setting it equal to 0 would mean I'd have negative 3 plus 5s equal to 0. And I can take the 3 across. That means I would have a positive 3 and a positive 5s here. I would then divide by 5 and divide by 5. The 0 pretty much goes away there. And then we're going to have s is equal to a positive 3/5. And if you'll notice, these are the same. And since they're the same root, what would we call that? This would be a what? A repeated root. Yes, very good. So this is a repeated, it's the same one, so it's called a repeated root. Okay, that takes care of the first page. Let's turn the page over and we will work on some of the examples on the back. And I'm not going to do all of these. We're going to work a few of these, but just to make sure you kind of have an idea of everything. We will do the first one here, number 7. And because it is a little different than what we've seen so far. So on this first one, it is a square, but it's of the same factor. Okay, so it's the same factor times itself. So we're going to have x minus 3 times x minus 3 equal to 0. Well, I really only have to do one of those to find out what my root is going to be. I just know that it's going to be the same root twice. So I'm going to set one of these equal to 0, and I know that I'll just have to take that 3 across. So x is going to equal 3. Again, this is the answer for both of them. Okay, this is the answer for both of those. And so this is also a repeated root. So you might make that notation. Okay, we'll skip 8 and 9. Let's look at number 10. Those are just more of the same of what we've already done. So let's go down to number 10. Just for sake of time, I think we're getting plenty of practice on some of these. On number 10, we have, in essence, we have 3 factors. This is actually w plus 4 is twice. Used twice here. We have w plus 4 times w plus 4 times w plus 1 equals 0. Again, you just take all the factors and set them equal to 0 and solve for the root or the solution. And this first one, just like the one we just did on number 7, we don't have to write that twice. We know that it's going to be the same thing, so we'll just write it one time and set it equal to 0. And that means that w is going to equal a negative 4, because negative 4 plus 4 will be a 0, right? Same thing as if we were moving this across the other side. It would change the sign to negative. So w equals a negative 4 is one of our roots. And then w plus 1 set to 0 will help us solve for the other root. And again, pretty simple here. We just take and move this across. That would be a negative 1, so w would equal a negative 1. Our two solutions or two roots would be a negative 4 and negative 1. On number 11, again, we have 3 factors. One of them is g, so that makes it pretty simple. We'll do this in different colors here to kind of separate it out. But we would have g equal to 0 for the first one. That one's pretty easy. Just setting that factor equal to 0 gives us the solution. And then the next one, we'd have 6 minus 3g equal to 0. We would, the easiest probably would be to take this across. So we'd have 6 equal to 3g. And then we're going to divide by 3 and divide by 3. And so g is going to equal a positive 2. Okay, so that's our second root. And then lastly, we have 6 plus 3g equal to 0. And we would take and move our 6 across to the other side. So that would make it negative 6. We have 3g equal to a negative 6. We'll divide by 3, and g is going to equal, these become a 1, a negative 2. So the three roots are going to be 0, a 2, or a negative 2. Okay? And that gives you a scenario with 3 factors again here. Number 12, you're going to have 3 factors. I'm not going to work the whole thing, but I do want to pull the middle one out, and let's work it because it does have a fraction. I know sometimes fractions make us a little bit nervous, but let me show you that that can be just as easy as the rest of them. Alright, so if we set that equal to 0, we're going to have 8 plus 2/3 m equal to 0. And if I was solving this, I'd put this one equal to 0, that one equal to 0, and get all of my roots. But at this time, I'm just going to work with this one. I'm going to take the 8 across to the other side. That means a negative 8 is going to be on the other side. I'm going to divide by a fraction, but we actually take that, flip it, and multiply. So I'm going to take, and I'll write this out, I'm going to multiply 2/3 m times 3/2. I flip and multiply. I've got a negative 8 over here, and I'm going to multiply that times 3/2. Okay, so that would help eliminate the fraction on the left side. M is going to equal, if I take negative 8 times 3, I get negative 24, divided by 2, negative 12. And again, that's not all of the roots or the solutions for number 12, but that is the one with a fraction in it, so that you kind of get an idea of how to work that one. All right, number 13, it says that we need to factor the polynomial. So now, we're not solving for anything, we're just going to factor. Okay, that means we're going to break this thing apart into its factors so that we can, maybe do something with this later, like solve and find our roots. But right now, we're just going to do the factoring. Okay, so the first one, we can break this into pieces if we need to. We could say that this is 2 times 3 times, and that one broke apart would be x times x. Okay, so there would be our, zoom in a little bit here, that would be our factors of the first term. Then we're going to add to that 3 times 1 times x, right? Or 3 times x, and we can have a 1 on there if we want to. So now, we're looking for the GCF. Does anybody know what GCF stands for? Greatest common factor. Yes, we're looking for the greatest common, meaning it's in both terms, factor. Okay? So we're looking for the greatest common factor. So on this first one, what's the largest factor that's in both terms? A 3, if we're looking at the integers, and if we're looking at variables, what is in both terms? An x, right? So we have a 3, I'll draw a little circle around this. I have a 3x in both of my terms. So I'm going to factor that out of the binomial. So I'm going to have 3x times, what's left in the first term? 2 and an x. So I'm going to have 2x. What's left in the last term? 1. Don't forget your 1s if you're taking everything away. Don't forget that there's still a 1 there. Okay, because if I take 3x and I divide it by 3x, what is anything over itself? Or divided by itself? It's just 1. So the answer would be 3x times 2x plus 1. And you can always check this. If you multiply 3x times 2x, you'd get 6x squared. If you multiply 3x times 1, you get 3x. Okay, so that is the factored form of 6x squared plus 3x. We found the greatest common factor, we pulled it out, and then we have the remaining factor for the product there. Okay? All right, number 14. Number 14, one of the things or the tricks that I will suggest to you guys as you're working these problems is first find out if the smaller integer term goes into the larger one, because that's going to be your greatest integer part of the factor. If you'll notice here, the 3 goes into 6. So 3 ended up being part of our factor, the greatest common factor. So in this one, does 4 go into 20? Yes. And so we know 4 is going to be one of the factors, or part of the factor, the greatest common factor that's in both of these. And we know there's going to be a y that we can pull out of both of these terms, but to what degree can we pull out? How many y's can we pull out of both of these? I know I can pull a 4y. I know I can pull 4y out because there's a y in both of these, but what's the largest y exponent I can pull out that's in both factors? 3. Because there's a y to the third here, and this is actually a y to the third times y to the first, so I can pull a y to the third power out there. Again, I have the 4, and this could be broke down into 4 times 5. So now, if I pull a 4y to the third out of both of these, then what's left? Well, in the first term, I'm left with a y to the first term. I took the 4 out, I took the y to the third out, and I'm left with y. And then, in this one, all I have left, because I took the 4 out, and I took the y to the third out, what's left? A 5. Okay, so if you're looking at those factors of each term, that's going to help you kind of find the greatest common factor. 4y third times y minus 5 in parentheses will give you the same polynomial that we have for the number 14. Okay, so let's box that in so we can make sure that we know those are the answers for that one. Let's look at number 15. On number 15, what can I pull out? I can pull out the 6, somebody says. I can pull the 6 out, and I can obviously pull a u out of both terms. So 6u is my largest or my greatest common factor. Well, 6u pulled out of this one right here leaves me what? If I divided 18 by 6, I get 3. Then if I take 1u away from the 4, how many u's do I have left? 3. I'll have u cubed. And then if I take 6u, divide 6u by 6u, what's left if I divide that by itself? A 1. Exactly, because and then, like I said, we could always check these because I can take this and multiply it back in to see if I get the answer up here. Okay? And that would be 18u to the fourth minus 6u. All right, number 16. We should be starting to get the hang of this. Can I pull out a 2 from 7? No, I can't. Not evenly, at least, right? And so it doesn't look like we're going to be able to use any numbers as part of our greatest common factor. In this case, I'm only going to be able to pull out a variable. And what's the least degree of exponent that's in both terms? You might want to look at it that way as well. What is the least degree that's in both terms? 6. So I can pull a z to the 6th power out of both terms because that's what's in that last term, and I'm basically going to pull that out. I know there's 6 in here because there's actually one more than that. So I will have 7, and what's left? 1z. And then the only thing left in the last term is the 2. So I'm factoring out the z to the 6th power. All right, number 17. What do we have on 17? If I've got, well, 8 going to 24. Yes, that's the first thing we want to look at, right? Well, 8 going to 24, and it will. So 8 is one of my greatest, or part of my greatest common factor. And obviously there's an h in both of these, so I can pull the whole thing out, the 8h out of the both terms. So if I pull 8h from 24h cubed, remember our little rule here. This might be a good time to throw this out there. Remember, when we're dividing, we're actually subtracting exponents, right? So this becomes a 3. 24 divided by 8 is 3. And this is actually h to the 3rd power minus 1. Remember, you're subtracting the exponents of your variables when you divide. So we're taking the 3 and the 1, and we're subtracting them. Okay? So what is that going to make? h to the 3 minus 1 makes 3h squared. Or again, if you pulled out one of your 3 h's that are being multiplied times each other, you'd have 2 left. And then I pulled out the 8h out of this one, so the only thing left is a 1. So that's my answer there. Okay, we'll skip number 18. It's much the same way. We could do it really fast. 15 goes into 45 3 times, so I know I can pull a 15 out. There's only one f here, so I can only pull one of the 4 out of this. So I'm going to have 15f as my greatest common factor. When I take the 15f, the 15 goes away. I'm left with f to the 3rd power minus, and 45 divided by the 15 would be 3. And f divided by f is 1. So I just have f cubed minus 3 is the second part of the factored form there. Okay, let's work the last few here. This is putting it all together. So we're going to factor it, and then we're going to solve like we did in the beginning. So if I'm looking at this one right here, the only thing in the second term is a k. So that's obviously the only thing we can pull out of both of them. There is a k obviously in the first one. So I can pull a k out. That leaves me with 6k plus 1 equals 0. And they want us to solve. So we're going to have to find out what k equals, or what the roots are, the solutions are. So setting the first term equal to 0, that's easy. K just equals 0. Working with the second one, 6k plus 1 equal to 0. I'll move this 1 across, so it makes it a negative 1. 6k equals a negative 1. I'll divide by 6 on both sides, and I'll write it over here on this side over here. K is going to equal negative 1 over 6. And it's okay to get a fraction. Don't panic. So the roots or the solutions for number 19 would be k equal to 0 or k equal to negative 1 over 6. Okay, number 20. Again, we're going to need to factor this first so that we can help us to solve for the roots. So I need to pull out the largest number. 35 doesn't go into 49. What are the factors of 35? Well, 1 and 35 and 5 and 7, yes. Okay, so if I broke this down into 5 times 7 times the n, right? And then 49, the factors of 49 are 1 and 49 or 7 times 7. So I have this broke down into 7 times n times n, right? And that all equals 0. Now, looking at the common factors in both of these, what can I pull out towards to the front? I can pull out a 7n out of both of them. I can pull 7n out of both of them. So I'll put 7n out front. That goes away, that goes away. What's my first term going to be? I'm only left with a 5. I minus, the only thing left here is a 7 times n, so 7n. And I set the whole thing still equal to 0. Now I can solve, I can find out which one of these, or find out if one of these equals to 0, what the n value would be to make it equal 0. Okay, so the first one, 7n equals 0. Well, if I divided both sides by 7, n still just equals 0. So that's an easy one. The next one, I set 5 minus 7n equal to 0. I can move the 7n across. That makes it positive. And so then I have 7n equal to 5. I divide by 7, and n is going to equal 7 over 7 is a 1, positive 5 over 7, and that would be my 2 roots for number 20. Okay, we're going to skip 21. That's going to be much of the same. Let's do one more of these bottom 3. Let's do number 23. Number 23. I need to move the 22 over with the s squared, or the 11s squared, so I can get a 0 on one side. So I'm going to take this 22 and I'm going to put it on the other side, which means I'm going to minus 22s. Okay, so my new equation is going to be 11s squared minus 22s equal to 0. And now now that this is set to equal 0, I have to get all of my terms on the same side and set the whole thing equal to 0 so that I can factor it and find out which one equals 0. So thus, we have to set the whole thing equal to 0 first. I can pull out an 11, because 11 goes into 22. I can pull out an s out of both of these. And so the remaining factor will be an s. After I pull 11s out of 11s squared, I'll have an s left, and I'll have 2 for 22s. If I divide that by 11s. And I'm going to set that equal to 0. And so I'm going to set the first part, 11s, the first factor equal to 0. And that just, when I divide by 11, s still just equals 0. And then the second part, s minus 2 equal to 0. Well, when I move my 2 across, that's positive. So s is just going to equal 2. Okay, so the 2 roots of solutions for number 23 are s equal to 0 or s equal to positive 2. All right, this concludes the notes and examples that we have here for factoring and solving the equation once you do factor. Hopefully this has got you a little more information on 7.5 and should help you get going on your notes. We will work on this tomorrow again in class. We'll work on the practice tomorrow. Thanks. Have a great day.